let's quickly my Zoom status has changed, and so I need to be admitting those who are in waiting. I'm sure by Monday I'll fix this problem. Okay, so let me quickly clean the board and then we'll look at how to look at solve this question using the two different methods. Okay, so we are told that a body B of moving with a velocity of this, so mass body B, okay, body B let me bring it down a little bit. We have body B, its mass is m, moving with a velocity 20 meters per second. So E of B, Jessica, please mute yourself. Velocity of B is 20 meters per second. Then we are told that it collides with a body A in the same moving in the same direction and on the same horizontal line with a velocity of 10 meters per second. So the velocity of A is 10 meters per second, and if the mass of body A is 3 times, so the mass of body A, we are told, is 3 times the mass of B. Velocity, initial velocity of A is equal to 10 meters per second. And the collision is perfectly elastic. Okay. If the collision is perfectly elastic, calculate the final velocities of A and B. All right. And then in the next question, we have to find the relative velocity. So this is the major issue at stake. Now, collision is perfectly elastic. And in perfectly elastic collision, momentum and kinetic energy are conserved. So if you write equation for conservation of momentum, so for conservation of momentum, you have mass of A, initial velocity of A, plus mass of B, initial velocity of B, equal to mass of A, final velocity of A, plus mass of B, times the final velocity of B. So put in the information as we were given. Mass of A, we are told, is 3 times the mass of B. So wherever I see mass of A, I'm going to substitute this, because mass of A is 3 times that. So I have 3 mb times initial velocity 20 plus mb times its initial velocity, which is 10, is equal to ma 3 mb times va, I don't know, plus mb times VB, which we are looking for. So when I multiply this and this, I have 60 MB plus I have 10 MB, which is equal to 3 MB VA plus MB VB. The next thing I will do is that hello, Amma.
Please, the velocity of A is 10 and not 20.
A velocity of
It's 10.
A. No, I'm talking of oh, okay. So it's like interchange it rather. This is
Yes,
10
please.
and then this is 20. Thank you. So it means I have 30 MB and this is 20 MB. Amma, thank you. MB is common at both sides of the equation. So we can divide through by MB. So we have 30 plus 20 is equal to 3 VA plus VB. But you have to, take note or write it somewhere that dividing through by MB, okay? So our final equation will be 50 is equal to 3 VA plus VB. And this is equation 1. Then write an equation for conservation of kinetic energy. So conservation of kinetic energy. Half MB squared. So half, let me get my markers right. Today, it looks as if my markers are, they have passed their usefulness. So half MAUA squared plus half MB UB squared is equal to half MAVA squared plus half MBVB squared. When you multiply 2 by 2, you eliminate all the half or fraction. Okay, so let's directly substitute MA and then MB respectively. MA is equal to 3 times MB. So 3 times MB times UA is 10. UA is 10. So 10 times 10 squared plus MB. But UB is 20. So 20 squared is equal to 3 MB VA squared plus MB VB squared. Please, class, I hope you are with me. Are you with me?
Yes.
Okay. All right. So let's simplify whatever we have here. 3 MB times 10 squared is 100 plus MB 20 squared is 400 is equal to 3 MB VA squared plus MB VB squared. Okay. Here, 300 when we multiply, we have 300 MB plus 400 MB equals what we have at the right-hand side equation. VB VA squared plus MB times VB squared. We can divide through by MB. MB is here, MB is here, MB is here, so we can eliminate MBs. Okay, so we have 300 plus 400 is equal to 3VA squared plus VB squared. VB squared. That is when we divide through by 300. When we add whatever we have at the left-hand side, we have 700 is equal to 3VA plus VB squared as equation 2. So now the bone of contention is solving equation 1 and 2 simultaneously. So equation 1, we have 50 is equal to 3VA plus VB. And equation 2, 700 is equal to 3VA squared plus VB squared. Our equation is such that, in fact, one is linear, this one is linear. Equation 1 is a linear equation. Then equation 2 is a quadratic equation. Okay. Before we can simplify, we'll make one of the variables the subject and substitute into equation 2. Okay, we'll make VB the subject and substitute VB into the equation 2. So VB is equal to 50 minus 3 VE. Okay, 50 minus 3 VA. So that we substitute this into equation 2. 700 is equal to 3 VE squared plus, this is VB squared. So wherever we see VB, we are going to substitute 50 minus 3 VA and then square it. Please, are we okay here? Are we okay with the substitution?
Yes, please.
So the next thing is to expand this. Now, if you have A minus B all squared, how do you expand this? Charlotte, how will you expand A minus B into bracket all squared?
Please, it will be A minus B, A minus B. So you get
Or
A squared minus 2AB plus B squared.
exactly. So let's apply that. As we have grown, so making that as A minus B, and then times A minus B is a lengthy method. So 700 is equal to 3VA squared plus, this is A, 50. So A squared. So 50 squared minus, and it is minus because this is negative 3VA. So negative 3VA times 50. And that is 150 VA, negative 150 VA times the power 2. So we have 300 VA. So this is 300 VA plus 3 VA squared. When we squared 3, we have 9. So 9 VA squared will be the square of negative 3VA squared. So that's the expansion of this one. So grouping of like terms. 3VA plus another 3VA. So we have 12VA squared. This is minus 300 VA. Now the square of 50 is 2500. Okay. We want to equate, we always want a positive value of the highest order. The highest order is the square. We want it to be positive, so it will still be here, but we equate everything to 0, and so we'll send 700 to the other side. So we have 0 is equal to 12VA squared minus 300 VA plus 2500 minus 700. And what is 2500 minus 700? What's that?
800. 1,800.
Okay. So plus 1,800. This is equal to 0. You see, we can further break this down to it's the least term, because I think 2 can go into this, and then 2 can also go into. Can we divide 2 by 4? Check and give me 300 divided by 4. I think that will be what? Is it 70 something? 300 divided by 4.
I think it's 75.
Come again. 75.
75.
Okay, and then check 1,800 divided by 4.
450.
Can we further divide through by 3? Check 75 divided by 3 and 450 divided by 3.
25 for the 75.
And then the 450.
150.
Pardon?
150.
Oh, okay. So we can further break it to the least term, minus 25 VA plus 150. Please, if you have a quadratic equation, you see it was like this. And I thought of breaking it down to the least term. This is proper because if you have large values and you solve, if you are not careful, you can get it wrong. The reason for me breaking it down further to the least term so that solving it becomes easy. So if you have done that, then you use the almighty formula. X is equal to negative plus or minus b squared minus 4ac all divided by 2a to find here oh, okay, I have to admit some students, sorry. All right, so whenever you are solving problems, quadratic and linear, this is what you do. When you compare, we are comparing I think squared, VA squared. We are comparing this to the quadratic equation formula 0 is equal to ax squared plus bx plus c. So when you compare, you realize that over here, a will be equal to 1 because our x is VA. A is equal to 1. B is equal to negative 25. C is equal to 150. Okay, so let's substitute it into the almighty quadratic equation formula to find VA. So X is VA. So V subscript A is equal to minus, and we have B to be already minus, so to be positive. So minus 25. So positive 25 plus or minus B squared, negative 25 squared. But when you square negative, it's still a positive. So it's the same as 25 squared minus 4 times A is 1. A is 1, C is 150. All divided by 2. 2A. I have to admit some people to. By man, they have to fix this Zoom problem. All right. So, okay. So please simplify what you have within the bracket and then give me the final answer. Square root of 25 squared minus that. So we have 25 plus or minus. Please finish this for me. Square root of 25 squared minus
5.
what?
5.
That is 5.
Yeah.
Okay. So 5 all on 2. Okay. So we have two answers for A. 25 plus 5 over 2 and 25 minus 5 over 2. These are the two possible answers for. So we have, this is 30. So 15 and this is 10. 25 minus 5 over 2. So the two possible answers for VA are 15 and 10. So if you found VA, let's find VB. We can get VB using the linear equation. Let's use the linear equation. We had 50 is equal to 3VA plus VB. So making VB the subject, you have 50 minus 3VA. So the first possible value of VB would be, this is 15. 15 times 3, 45. So 5. And the other value of A, 10. So 50 minus 30, which will be 20. So these are the two possible values of VA. In fact, when you use the simultaneous equation, you are always getting two values for the variables in question. Okay. This goes with 15 and then 5, then 10 and 20. Any of this pair of values would work. So for the simultaneous equation, class, this is what to expect. We are going to use the coefficient of restitution to see what to also get for from that. Any question? If you have any question, ask.
Mr. Dia, please, can you send your camera up small? Thank you.
So can I clean the board?
Please, can you rather move it down? The downside, the conversion to kinetic energy.
Are you there? So whenever you are solving a quadratic equation, please take your time and always try to reduce the numbers to their least term. Do not jam them up, go large coefficients, and then you try to solve them. No. When you do that and your mathematics isn't strong, you can easily get it wrong. So you always try to reduce numbers to the least term as quickly as possible. Okay. Can I continue?
Yes, please.
All right. I'm cleaning the board. I'm recording, so you can always have the video too. So take note of the answers. Using the coefficient of restitution, we can always get one value for A and one value for B. But once let's check the answers and then know which one is which. So it means that whenever you are given a question and you use any of these methods, whatever you get, so long as the answer can be or can feature in any of the equation or methods you place, you are right. Do not think that, oh, because here I couldn't get two answers, so I'm wrong. No. So MA, we are told is 3 times MB. UA, UA is 10 or 20. Charlotte, is UA 10 or 20?
Please, your question again.
I said, is UA 10 or 20? Velocity of
It's
A.
10.
Okay. Then UB 20
It's
meter
20.
per. Okay. So yes, you can write equation for conservation of momentum. So 3 MB times 10 plus MB times 20 is equal to 3 MB times VA plus 3 times MB times VB. But with the coefficient of restitution method, you are always either using conservation of momentum or conservation of kinetic energy. So you are free to use one of them. And so I am choosing conservation of momentum because that will give me a linear equation. So 30 plus 20 is equal to 3 VA plus VB. I will choose this. So I have 3 VA plus VB equals to 50. Then use the coefficient of restitution formula, or if you use the coefficient of restitution, E is equal to V2 minus V1, here A and B, over, this is VB minus VA over UA minus UB. You are told the equation is perfectly elastic, and so E is equal to 1. Let me bring it here. E is equal to 1. Or write relative velocity of approach equals relative velocity of separation. Each of it will do. So when you substitute the value of E, you will come back to that equation. Relative velocity of approach being equal to relative velocity of separation. Okay. Because the bodies were moving in the same direction, 30 minus 20 is equal to VB minus VA. Let's make VB the subject. VB is equal to 10 plus VA. So you have equation 1. You have this as equation 2.